Okay. Right, good. So then we continue. So then Pedro will tell us about Vagrant software that he has been using.
Okay, so I'm thank you. I have opted for showing you Vagrant in a training environment, and to do that, I would like to first of all introduce you to the materials that I have put up. So I have created in the GitHub a few MD files that would allow me to speak about this without slides, but I also did a slide session that we can use here. And so we have, to make it simpler to explain, I come from Portugal, where I run a bioinformatics training program on a very regular basis since 1999. I work for the Gulbenkian Institute of Science, called Instituto Gulbenkian de Ciência, and I am the training coordinator for Portugal for ELIXIR, and I am one of the original members of Goblet. So I am deeply involved in training organizations. So the TPV program that I run in Oeiras in Portugal has held more than 300 courses, now 338 if I'm not mistaken, more than 4,700 participants, and our major guidelines are that we want to provide training for bioinformatics users, not so much developers, but more users. And so we constantly survey the user needs, and we try to improve on the training methods. So in the year 2015, we have run 12 courses. These are the titles. And you can see that we do an introductory course twice per year, and then we do several thematic courses, and we do some courses that are going to the root needs of the users. For example, I feel that many users of bioinformatics tools are strongly deficient in statistics, and that the universities are not providing us with people that are sufficiently agile in statistical methods usage. So this course, for example, this is like a semester course in 5 days. It's very, very intensive, but it brings people up to that. Likewise, there is here a course on programming that is actually delivered by Allegra, who is in the back here. And this course was delivered by Bert, who is there. So we end up not being... Sorry? Part of it, yes. So in this course, we do a 2-day NGS introduction, but before that, we explain people about methods to handle sequence data. So in the year 2012, we detected one of these needs, and this need was connected to the problem of reproducibility, which we found is worse when you do complex jobs like workflows or pipelines. We found more and more that people had difficulty in explaining, for example, in a paper or to a referee, what they had done to make a specific analysis, to reproduce this analysis, to transmit to others what the analysis was consisting of. And so this is the motivation for introducing virtual environments in cloud. So we were after an objective that is not only the technology, not only the techniques, but the use of the techniques to have more reproducible work. And so we found that with the reasons for this is that authors are often not aware that they should use revision controls in their files, in the scripts. they were not so much concerned about the portability, changing their workflow to another, say, hardware or software platform. They did not foresee the consequences of software updates. So when you have, you call several programs, and in the middle you change a version, and sometimes it has consequences on the results. They did not consider recording parameter changes, and this is particularly bad when you use software that has point-click interfaces, drop-down lists, sliders. I mean, who is going to record what your sequence of choices were? And above all this, there is a certain lack of consciousness that data itself is not stable. And the most typical example is if you use reference genomes. The same workflow with a different reference genome can give totally different results. And so you need to associate in a reproducible way, to associate the reference genomes that you use with the analysis that you have been recording. So initially, in 2012, we produced a first design for this course, which was mostly insisting on telling people what the good practices are, standardization and so on, introducing technologies. At that time, most of the things that we are using nowadays were still not available. And then we illustrated with use cases. And right next, I will show you what we did this year, 2 weeks ago. So it looks very simplified compared to the first one. And so basically we have now access to all these tools, and we introduce people to the techniques, and we make them compare with their own heads and hands, make them compare the virtues of using one or the other way. So this is as you can see, there is a difference between 2012 and 2016. We have not repeated this course, I think, in 2014, but we did 4 of these courses up to now. And so this is the group of, it was only 8 people and 2 instructors. This is Rutger Vos, who should be in this workshop, in my opinion, but it was impossible to invite him. He's from the Netherlands, a place in Leiden called Naturalis, and this is one of his collaborators that came in place of Dan in London, who lives in the United States and couldn't come because his mother passed away. So in emergency, this guy came, and he is a collaborator. All the rest are people following the course. As you can see, there's people of all ages. There is people in the 20s and people in the 60s, like Luciano Milanesi. Yeah? Oh, this is 21st century. This is 18th century. Yeah, it's not the institute. It's next door. Okay, so I think you've been there. Yeah. So one of the things that we introduced to them was the use of Vagrant, and Vagrant is sometimes a choice in virtualization that is chosen by developers as opposed to users that just want to launch their scripts. And so, Vagrant is basically a way of specifying and managing virtualization through a file. So you have to maintain a file. We teach people to maintain the file with Git for versioning, but the file is a Ruby script, but you can barely notice it. You will see an example in a minute. But if we look at the file, most of the file is comments, and we explain what is going on. And then you command the use of visualization by issuing commands like this one. So init up, SSH, halt, destroy. So there's a couple more than this, but basically it's using the host software, the host machine, to issue commands to the virtualized machine, putting it up, putting it down, destroying, initiating, and so on. So a simple Vagrant file could be something like this. I removed most of the comments, otherwise it could be enormous. Basically, it has statements like VirtualBox GUI on or off, or the amount of memory, or things like this. So it has a very simple way of specifying, and it is much more. If you see the original file of this, the comments are mostly enough for us to understand quite well what the statements mean. So I will, after this presentation in slides, I will show you the repository of the course that is available to you, so you can follow not only the Vagrant part, but also the Docker part and the initial part with Git. And so the formula in this training course is basically to tell people, virtualize your files first. Second, use a virtualization platform that is adequate for your problem. We teach people how to choose. And once you choose, be sure that it's correctly parameterized. And then we let people play with images and boxes in a way that is in which they can have a look and feel. The course takes 5 days to complete. So we then put up the concept of a Vagrant box, which is more than just creating an image. Is an image that contains a functionality, and the functionality that is minimal is to have a package manager, which is adequate to the type of Linux that it carries, an SSH server, a defined user, and a provisioning system. And this is something that I would like to insist. It's a bit external to Vagrant, as you can imagine, but it's strongly connected because Vagrant was very early pioneer in using provisioning systems, and the major ones are Chef and Puppet. So the concept is that you have, on top of the basic things that allow you to manipulate your Linux system, it could be an empty Linux system with no applications. But with the provisioning method, this comes a bit from the military, in which they have warehouses, and the warehouses have manifests, or like in a ship, you have a manifest, which is a complete description of the load of your ship. So likewise, Chef and Puppet are software packages that allow you to specify collections of software that you want included in your system. And so this set defines what a box is. And you can create boxes like this and use them in your local system. That's what they do in the training room. They have a Linux system on their desk, and they put it up there. They need a VM to put it up, but they also learn in the course how to put these boxes in providers like Amazon, for example, and to do that they use a software called Packer. So the description of Vagrant is very complete, but very simple. You don't need to read much. This is made by developers, and you know that developers don't like to make very long manual pages. Nobody has patience to read them. So it is shorthand documentation, but it is quite well written. So in provisioning, we chose not Chef, but Puppet. The difference is not enormous. The syntactic way of dealing with it is different. Chef has a culinary, as the name indicates, culinary terminology. Puppet has, but basically what it does is in a JSON file, which is source code. You don't see very much code there, but it's a JSON specification, I could say, I want my system to have wget, bzip, tar, git, build essential to develop code, gzip, libg development, and curses, and so on. So I could describe these commands. And basically you describe the way they are downloaded. So basically you have a section for the wget where you tell the system where to get sources, then the way to compile and link, and then the way to use and to deploy in the target system. So in terms of Vagrant, and this is where Vagrant wins a lot, because it's very simple to manipulate. You just issue the command Vagrant provision, and when this is issued, Vagrant goes to the Vagrant file and discovers a section that says Puppet, and in the Puppet section it goes into the Puppet description file and executes from there. So there is no more synthetic way than this. This is it's a command. It's a really economical way. Then I would like to show you, also by comparison with the diagram that we saw yesterday, that the learners in the course, not the teachers, the learners in the course were invited to make a comparison. So when they were sufficiently aware of how to use Vagrant and Docker, so this is the 4th day of the course, at the end of the day we asked them, can you help us to make a table? And we list what you find relevant in terms of comparison. And I would not choose some of these items. I would not choose this order in particular, but this is the content of the course as seen by the participants, which I think is relevant for us to discuss here. And so they were amazed with the security. I added the potential there because they didn't have the potential, but I put the potential there because I think it's unfair. But and they agreed. But there is a certain ease of disrupting security if you use Docker that does not exist in Vagrant, because Vagrant has the philosophy of a sandbox, so it's isolated from the environment. You can do dangerous things that don't propagate outside. Basically, it's the idea of the sandbox. And with Docker, we played in a demonstration. We played the dangerous role. And if you are curious about how to be disruptive there, I can explain that one way of being disruptive is to map, to use the Docker launching command to map a virtual machine path to a physical host machine path that can be /etc, can be something dangerous. And the issue there is that it is not advised to do that. It's a very bad idea, but it is possible. You don't need to be a criminal. You can just be ignorant. It is possible to launch Docker, and in a way in which these paths are permeable. So from the target machine, the virtual machine, you can access dangerous paths in the host machine. So this is why, for example, when you propose to a system manager to install a Docker box in a physical Linux system, most of the times he reacts negatively, because they don't teach people, but they know that this exists. And so the problem with this is that Docker boxes run as root, and the root permissions are inherited. So they go into the host system from the hosted system to the host system with root permissions, with a path that we allow it to have. And so you can do very damaging things to the host system. So they were very impressed. They put it in the top. But this is the reaction, the normal reaction of a newcomer to the field. You say something that is stunning and you put it in the top. But I find this table interesting because they of the choice of things that they elected to be compared, and here, and as this talk is mostly about Vagrant, I would underline that Vagrant provides an entire OS, so it's isolated from the host system. It's an entire OS, completely standalone. It does require you to have some virtualization system in place and Vagrant itself, whereas Docker only requires Docker. It uses Ruby as a scripting language, whereas Docker has its own language, as you will see in the rest of the workshop. They found it relevant to say that Vagrant is easy to deploy on a grid, whereas in Docker they had big doubts about that. And they also looked at the negative aspects. So, for example, to use message passing interface in clusters with Vagrant images, they found it not so nice to work with. And basically that's it. So if you want to, outside of the scope of the course that we gave, if you want to see a fully fledged system that is done by these two instructors that I had in my place, is entirely made by them. A fully fledged system that is completely open. You can look at the Git and whatever, but uses Vagrant for virtualization. Maybe it's a good idea to have a look at this system because it's very well built, very robust. It has lots of things to learn about in terms of virtualization. You can explore entirely. So there's also a slide session. There is a paper that is in preprint. There is a project description. So it's very well documented, and you can see in detail how they configured it, how they built the project. And last, I would like to say something that I think is relevant, not only for Vagrant, but for the rest, is that virtualization, for me, has two meanings in bioinformatics training. So one meaning is, it comes from the fact that you are using techniques that allow you to create environments that are reproducible. And this is one motivation to train people in virtualization. Another usage in training is that you can deliver a course on whatever subject, and you may want to have a snapshot of the course, of the environment of the course, so that it can be placed elsewhere, or played again, or exactly with the same environment. And here you have, this is another course that I held earlier in the year. It's about, this one is about doing RNA-seq and chip-seq using R scripts and bioconductor. And in this GitHub address, you will see, I can play it here. So this is a normal GitHub that supports the course, and then Git generates Git pages, so it looks beautiful. This way, it's like selling a product. And so this is a course that is held. The content is held on GitHub. You can, with these buttons, download the entire course. It's open there. So this is the group of people. So the description is rather complete over here, day by day. But what I wanted to show you is that here you have a Docker file. So at the end of the course, we can make a Docker file and specify how a Docker container can contain the whole material for the course. The data files, the scripts, everything, the slides. So this is a way of documenting a course that is almost a luxury. You can take a snapshot and pack it there. So this is, in my opinion, another way of looking at virtualization and these techniques that gives another meaning to using virtualization in training, is that you can package courses and ship them and reproduce them and repeat them wherever you want. Also for the participants in the course, having this capability compared to taking PowerPoint decks of slides, this is a lot better. So they really like this kind of thing. So coming back to the course on virtualization, the GitHub for this course is here. And you will see that in the GitHub of this workshop, you have the address to this. And this is, again, a complete description. It is not beautified with the Git pages yet, but it has a very detailed description, lots of references. Okay, and the organization of the GitHub is such that you have access to folders that, I mean, a developer would put folders like this. This is the imprint of a developer. A normal teacher wouldn't do a thing like this, put a bin folder or something like this. But if you want to navigate easily in here, you can see that the documentation of the course is done day by day. So if you do this, you see the dates and you see what was done in each date. The first day was dedicated to Git and versioning. The second day, as you can see, we started virtualizing and using Vagrant, and then provisioning. Okay, and then session by session, you have here a description that contain the assignments. So in a training course, that, in my opinion, a well-designed training course is developed from the exercises up. So you define an overall objective, a learning objective, but then you create a series of exercises. For the exercises, you have very well-defined learning outcomes, not objectives, outcomes, things that are measurable. And the exercises here are called assignments. So if you look at the Vagrant exercise, you will see that it is written in great detail and with hyperlinks. So there is a concrete task that allows you to learn without a teacher, to learn how to use Vagrant. And so you can also see that the Vagrant folder, which is accessible via the top under the date as well, so it's under the date, you have the Vagrant file that we used. As you can see, it has lots of comments, and you can recognize the commands that I took to the slide. They are not commented, but these are the same. Most of this is comments, but the comments are there for a purpose. It's not for beautifying. It's for us to understand later what they are doing. But aside from that, you can see that aside from the Vagrant file itself, you have the exercise here. And the exercise at this stage was a simplified exercise. So the idea in a training course, you don't want to waste time with unneeded things. So why use Vagrant to create a complex system for a start? Why not use a very tiny little system just to check your capabilities? So basically, it tells you install Vagrant. You click here and you have the Vagrant site that has a download button. Then it tells you, have a look at the available Vagrant boxes, so ready-made systems for platforms. It is relatively important to stress that when you are choosing these boxes, you should take care of the type of system for 32 and 64 bits and with several flavors, Debian, Ubuntu, and so on. And then you can filter these selections with criteria that you can use these buttons with. It is also important to know where you want to deploy this system at. So if you are using, like in a training room like this one, a system that has a Linux installed and possibly VirtualBox, I would suspect, I haven't checked, but VirtualBox, then you should take care that your Vagrant knows which version of VirtualBox we are using. There may be dependencies there. Not necessarily, but there may be. And then you continue and you go into this, you edit the Vagrant file if you need, change the amount of RAM or whatever, turn on the GUI like the Vagrant file that I was in the slide, specify the type of shell. So the instructions are in this level of detail. Anybody can do this. And then at the end, it instructs you to destroy, to erase what you've done, because this is a useless thing. I mean, you create a Linux that barely works, but it's an exercise. So typically, you want to leave the room clean after the exercise. So then the course continues. If you look on the other sessions, you can see here that the assignments continue. This one is the assignment regarding the provisioning, specifying the software that you want in your system. So this is rather GNU-ish, but it has the instructions to get Puppet and put it to running state. And then you have a typical provisioning script that you can see. So as I described before, there is a definition of paths, but this is almost irrelevant. You have then a description of the packages that you want in. But this is just a description that says, don't start the system without ensuring that this is there. And to install it, it requires an update before. Then there is a series of executions that allow you to command this to Vagrant. So you can command Vagrant to download BWA or to untar BWA or to make BWA in sequence. And then the same for SAMtools. And why BWA and SAMtools? Because in this course, what we did was to give people a very simple RNA-seq job. A very simple one, but one in which reproducibility matters. And so we want BWA and SAMtools to be there in order to run the pipeline. And then to actually use the material of the system, we clone from GitHub the content of the course into the target system. And then we make some permission changes, and that's it. This is the provisioning file. So as you can see, this is a very simple way of provisioning. You just specify what you want, how you install, how you control the permission, and so on. So when this is done, remember, this is the default PP, this is the default Puppet description file that is actually called within the Vagrant file. So when we put the Vagrant up and we say Vagrant provision, what it does is to look for this default PP and look at the software that we want and provision the system. So the end result of that is a Linux system that is specified in the Vagrant file and provided with this application software described by Puppet. So that's the way it works. So At this stage, so we then instruct people to do a git merge and actually run the pipeline and see if the results are reproduced. So this is basically the description of the docs folder that has the day-by-day description of the course. We have for the course a conf directory that has definitions. So the template of the JSON file that is used by Vagrant and so on. One thing that you might want to have a look at, because it's a very interesting training technique. I'm not sure if we can do this here. Can we install software? Yeah, here. Maybe not. No, but in the laptops maybe they can. So there is a very interesting software called XMind that makes mind maps. And one of the things that we do in my course program, not in every course, but when it's interesting to do that, we ask people to make a visual description of the ideas that they capture during the course in a map that has boxes and arrows. So they have a visual description of the content. And in this course, you happen to have access to that because you can see here. You can see here that in the first day, for example, we have these files, xmind. This first day, as you can remember, it's about Git and version control. So we have a teacher-made diagram of version control, how Git works visually. I don't have. Maybe can I install software here? Maybe it's fast enough. Maybe it's locked.
You can try, but I think.
Yeah, I would need probably root access, but you can do this in your laptops or at home. Xmind is freely available for every platform. It's a very simple, short software that allows you to make mind maps. So with that software installed, you can inspect all these mind maps. And you have here a map of the whole content of day one, for example. And if you go to day two, again, you have here, well, you have for the whole course a mind map, which is, I'm going just to see the raw file because it's probably inspectable with a simple editor. Maybe Notepad, something simple. It's not very beautiful, but basically it has a description of a diagram that the program interprets. So you can generate a mind map for the whole thing. And you can see, because I have one here that is in, would play in this one because it's probably in PDF. No. This one, this is not a mind map, but it's a very similar idea. So, no, this is the cheat sheet, so not this. So these are mind maps contributed by the participants. And this is, again, something that I would like to share with you. This is a good method to check if the ideas perceived by the students match between them and if they match with the teacher's idea, with the instructor's idea. So the instructor can make a mind map. He doesn't show the participants. he asks the participants, for example, in a recapitulation session or something like this, to create a mind map that they do on the fly. And then they converge all the mind maps together, and then we can collectively compare them and see if the perceived connection between ideas of Mr. X and Mrs. X, and if they match or not, and if they compare well to the idea of the instructor. So these are the names of the participants. I am sorry, I cannot find here the there is a global mind map that I think I have in PDF form somewhere. But anyway, it's possible to depict conceptual capture by the participants and compare collectively and discuss. And this is it. This is what I have to say about using virtualization in a training environment. I didn't give you a training course on on Vagrant, but I provided a training course in Git form that you can follow, and I think it's in a rather simple form. You could do this without help. Thank you.